All right, welcome everybody. This is assignment 4 of our unit. Again, we are getting real close to the end. This is, I believe, actually might be the last assignment. I know it's the last topics that we have to cover. Today, we are going to be seeing a lot of word problems, and it's all based upon random vocabulary words that we really kind of need to focus on. And so the title of this lesson and the 6 words that you really kind of need to focus on are random and biased, sample and census, quantitative and qualitative. And I'll kind of break down little mini lessons as we go along here to help identify what things are. So the very first 2 words that we're going to be seeing in problems 1 and 2 are random and biased. And so let me kind of jump to a different screen and kind of explain what those 2 things are. Okay, if something is random and biased, random and biased. Okay, random and biased. It's good. This is what you strive for. You want things random, and biased is bad. Okay, what this is all dealing with is a concept in which, and I'll get into it a little bit later, is, okay, say you have a population of people, okay? A population of people is all the people that you want to know about, okay? You have a bunch of different people. And okay, you have just a bunch of different people, all you know, that you want to know about this collection of blue people here. Now, it wouldn't make much sense to ask every single one of this population a question because it's too big. There's too many people, and it would be a big headache to actually get this. Now, but how do I elicit information from these people that is accurate? Like what percentage of these people are left-handed? You know, what percentage of these people enjoy the statistics class? You know, like, so you don't know until you ask, and you have to ask them a question. Now, how do you ask that question? Well, that is the exact split between a random and a biased way about going about asking somebody. If it's random, okay, again, that's what you strive for. That's what you want. And how you get random is you don't interject any bad things into the question. Like, you ask the question in a fair way. A lot of times you don't know the outcome before you ask the question. Like, I don't know what percentage of these people are left-handed, so how can I go about getting that information in the fairest possible way? And so different ways to do that is, you know, like, ask every 3rd person. Okay, so it'd be like 1, 2, you, 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 1, 2, you. Every 3rd person. Now, I don't know who the 3rd person will be, but what I'm doing is I'm getting, if you think of this as a population, I'm getting a random scattering of people throughout the population. I'm not secluding my sampling to just, like, you know, the first 4 people or something like that. I'm not doing that. I'm getting a fair and equitable representation of everybody. Okay, so that is one way that you can go about getting a random sample is like every 3rd person kind of concept. Another way that you can do it is a thing called a random number generator. A random number generator. And what a random number generator is like a computer system that comes up with a number at random. So like think of like a slot machine, and it cycles through all these numbers, and then ding, it comes up with the number 9. All right, number 9, come on down, kind of idea. And so if you use a random number generator, a lot of times that gets a random sampling. So if everybody, if the blue population was assigned a number, year 1, year 2, year 3, year 4, et cetera, et cetera, et cetera, and then I use a random number generator. So number 9, number 3, number 2, number 14, you know, like it doesn't have any bias. It doesn't know who these people are or anything. And so again, you're getting that random scattering that we're looking for out of the population. So random number generator. Okay, so those are ideas of random. All right, random number generator. Okay, biased. And biased is identifiable by a lot of times, like you're putting, you know the answer before you ask the question. Like by the way you ask the question, to whom you ask the question, it imposes bias. You're not getting a random scattering that you need. Like, so to know something about a population, you have to ask the population. So everybody in the population has to have a chance to be asked. All right? Everybody has to have a chance to be asked. Now, obviously not everybody will be asked. That's not the point. But everybody had a chance to be asked is the point. And you're not getting information from like a little corner of the population. You're not only getting information from a slight little sliver of them. You know, of ways to be biased is if you know the answer already. Right, and one way that I kind of ask this is, or I present this, is, you know, I want to, like me personally, I want to show that, you know, people have long hair. People have long hair. And so how can I ask a question that will show a high percentage of people have long hair? So take our population here. What question would you ask that population knowing that you're going to get the answer of, yes, we have long hair? Like, how would you ask a question? To whom would you ask the question? Things like that. And one way that you could do that, you could get an answer of, hey, all of these people have long hair, is I'm going to ask just the females. I'm going to ask just the females. How long is your hair? And then typically females have longer hair than males. And so, but if I'm only getting the information from the females, you know, it will say that this entire population has long hair. Because my answer will be a large answer. Again, I didn't ask everybody. I only asked some of these people, but the people that I did ask just so happen to have long hair. So the information from a few represents the many, that's the idea, but I knew the answer before I asked the question. I knew the answer before I asked the question. It's how I ask the question, to whom you ask the question, those sort of things. A typical idea behind this is I want to know, what is the satisfaction rating of people and parking? So let's say all of these people attended you know, a town hall meeting or something like that. They all attended. And I want to know, as the business owner or the place owner, how is my parking? All right, well, if you were to do that randomly, what I would do is I would ask every third person coming through the door, hey, how was the parking? Good, awesome, thanks. How was the parking? Oh, it's awful. Well, sorry about it, but thank you for answering my question. Go on. If I were to do it biased, what I would do is I would ask, you know, the first 5 people walking in through the door, how was the parking? Because what are these people going to say? Parking was spectacular. I could park anywhere I want. I double parked. I took the handicap spot. Like they parked anywhere they wanted because there was a ton of parking. But what do you think these last 5 people would say? Was parking as joyous as the first 5 people? No. They would say, oh, parking was awful. Because everybody else parked in their spots. Like, it was really hard. They had to, park on the side streets and things like that. So no, parking was awful in their experience. So by asking the first 5 people, that would be a biased way of asking the question, because I knew the result by whom I asked the question. The last way something can be biased is if you interject your own personal opinion into the question itself. Let's say that these are members of the public and they are going to go vote for a local representative. They're going to vote in politics. Now, you can't interject your own influence into the question. So how I ask a question is really important. Like, are you going to vote for candidate A, or are you going to vote for candidate B? That would be a random way of doing it. That's a good way of asking. You can't interject your own personal opinion. You can't say, hey, are you going to vote for person A, who is an upstanding citizen? They donate, they volunteer at the local animal shelter. They bat a solid .75, 75% batting average, and they're just an all-around swell person with a good family. Or are you going to vote for person B, who kicks random dogs whenever he can, and he never returns his shopping cart to the cart stall, and it's just an all-around scumbag? Who are you going to vote for? Everybody, if they didn't know, would vote for person A. It's like, oh yeah, I'm going to vote for A. Like, now, is that, like, are you getting a true result of what these people actually would have done? No, because you put your own personal influence into the question. All right, so that would be a bias. So random is good, bias is bad. All right, let's kind of did that one until to death. So let's take a look here. Let's go back here. A sample was conducted to determine which sport is the most popular in Arizona. 100 randomly selected people standing outside Chase Field, Diamondbacks Field, were asked, what sport is your favorite? Was this random or biased? Okay, so the population that I wanted to know about is which sport is most popular in Arizona. So Arizona people, I guess. Okay, now did I ask Arizona people in that sort of fashion? Or did I ask in a biased fashion? And the answer is bias, because I only got the people standing outside of Chase Field. What is their answer going to be? What sport is their favorite? If you're standing outside the Diamondbacks field, they're probably going to say baseball. You know the answer before you asked it. All right? So is this random or biased? Biased. Why? You're outside a baseball field. That's why. All right. 2. Sample was conducted, determine which movie is going to receive the most revenue at a particular movie theater. Okay, so here's your movie theater. We're looking to achieve this. Do we achieve this? Every 10th person entering the theater was asked, what movie are you planning to watch? Was this sample random or biased? So every 10th person, so 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 10, 10. Yeah, so I'm not getting a selection. I'm not going to fall into everybody that, went and saw a particular movie at a particular time on every 10th person throughout the day. So this is random. Random. Why? Because everybody had a chance to be asked. Okay, you want to know how many play? Oh, I wrote this problem a while ago. R.I.P. Kobe. Okay, census and sample. Let's go to another thing. All right, so 2 words: census, sample. All right, you want to do a census. Why? Because the results are the most accurate. There is no guesswork in the answer itself. You know exactly what the answer is. There is no guessing. All right? And so what a census and a sample is this. Let's say this is your population. Okay? This is your population. And you want to know something about that population. And how you get information is you can take a census or you can take a sample. And again, samples can be subdivided into random and biased. Okay? Census. If you take a census, what you have to do is, if this is the population, you have to ask everybody 100% of that population. You have to ask 100% of that population. You can't miss anybody. So if you want to know a question, an answer to something, you have to ask everybody, regardless of how big that population is. Okay, if you're taking a sample, you're not asking everybody of that population. What you're doing is you're asking, some of the population. Okay, this is my sample. You're asking some of the population, and the sample, let's call it, let's say 20% or something like that. This 20% of the population represents the entire population. So the answers based upon that 20% will tell you about the population itself. So that is what a sample is. So census is obviously the most accurate. What percentage of people are left-handed? You will get an exact answer. It'll say 13.7246%. Where a sample will say, about 15%. Based upon whom we asked, we got an answer of 15%. Now, so samples are less accurate. Now, why would you ever take a sample? If censuses are so accurate, why would we settle for anything less accurate? And it boils down to the simple fact of, what is your population size? Okay, what is your population size? If your population is huge, let's say that this circle represents 3 million people. All right, it represents 3 million people. Are you going to ask all 3 million people, are you left-handed? Are you going to ask that question 3 million times to get your answer? No, that's silly. All right? So when the population is large, that's when you want to do a sample. Okay, instead of asking 3 million people, I'm going to ask 20 people. And 20 people are going to represent this 30 million people. I can ask 20 people a question. Are you left-handed? I can ask that to 20 people. Not a problem. All right? But I'm not going to sit there and ask 3 million people a question. So the population was way too large. So I am going to take a sample. Now, if the population is relatively small, let's say that there are, 15 kids in a class, and you want to know, of those 15 kids, what percentage of them understand what they did on their homework. Would you take a census or a sample? I would take a census in that situation, because I will get the most accurate results, and I can ask 15 people that question. So I'm not sacrificing accuracy, because that is a manageable size. Okay, so when the population is relatively small, then you can go ahead and take a census. Now, the hardest part about this whole thing, though, is identifying the population in the first place. Who do you want to know about? That is the population. Who do you want to know about? And so don't be distracted by the question that is being asked. That's just a distractor. What you need to do is focus on the population itself. Don't worry about the question that they're trying to get, but rather who is being asked. Okay. Let's take a look here. Again, rest in peace, Cody. All right, you want to know how many players on your school's basketball team like Michael Jordan more than Kobe Bryant? Okay, would you take a census or a sample? Okay, again, don't be distracted by the question. Don't be distracted by the question. Focus on, who do you want to know about? You want to know about players on your school's basketball team. That is the population that you want to know about. So, how many people is that? How many people are on your school's basketball team? And so if you think about all levels, et cetera, you're talking about maybe 30 people or so. Okay, it's 30 people. Okay, can you simply ask 30 people that question? Yeah, you can ask 30 people a question. So I would take a census. Okay, why? Because the population is manageable, is small. Okay, it's manageable. You can ask your school's basketball team, you like Kobe Bryant or Michael Jordan? All right, so you can ask that question. All right, number 4. You want to know how many teenagers in Arizona like doing their homework. Do you take a census or a sample? Again, don't be distracted by the question. All right, don't be distracted by the question. Focus on, who do you want to know about? teenagers in Arizona. You want to know how many teenagers in Arizona. That's the population. So stop reading the question and just focus on who is being asked. Who do you want to know about? All right, so are you going to, like, what is the size of teenagers in Arizona? Like, how big of a population is that? That's millions. There's millions of teenagers in Arizona. So are you going to ask millions of people a question? No, you need to cut that down. You need to take a sample. You're going to sacrifice accuracy because it would not make sense to ask millions of people this silly question. All right, so sample. Why would you take a sample? Because the population was too large. Okay, because the population is too big. That's why. Good grading. And last but not least, quantitative and qualitative. Quantitative. Qualitative. All right, quantity. Quantitative is a quantity. All right, it's how much of something. Okay, the bottom line, what a quantity is, it's a measurement. Okay, it's a measurement. All right, it's how many people are in a classroom. It's how many gigabytes your computer can hold. It's how many ounces fill a water bottle. It's it's not numbers, it's measurement. It's measurement. There are numbers that aren't measurements. Things that aren't measurements are like numbers are like phone numbers. A phone number is not a measurement. Your address, your house number is not a measurement. Things like that. Your zip code is not a measurement. But there are obviously a lot of numbers that are measurements. You know, your height, your weight, your age, your things like that. Those are measurements. Those are quantitative if it is a measurement. Qualitative is a quality. What a quality is something that is kind of intangible. It's something that, well, pretty simply, is not a measurement. Okay, is not a measurement. It's indescript. It describes something as a quality, and it's like so it's a description. Description. Whatever. Description. Description. Whatever. I'm a mathematician, not a English person. So it's a description of something, but what that is like, how did it smell? It smelled good. You know, it looked old. That's not a measurement. I mean, it's kind of hinting towards a measurement, but it's not a measurement. It's good. It's old. You're fresh. Something like that. You know, these are just descriptions of something, and those are qualitative qualities. So quantity is a measurement. Okay, everything else is just a category. It's in the category of good. All right. So here we go. Identify the variable as being qualitative or quantitative. The computer was old and dusty. There's not a measurement in that thing. That is all qualitative. Identify the variable as being qualitative or quantitative. The computer had 40 gigabytes of, that's a measurement. There you go. And that's what it is. All right, so let's rush through the backside here. Just make sure we know what's up. A sample was constructed to determine which brand of pencil is used the most at your school. Random algebra students were asked what brand of pencil do you use the most? Was this sample random or biased? Okay, so I want to know, the population is to determine which brand of pop is most at your school. That's the population, school. Who did we ask? Random algebra students. Are random algebra students representative of the school at large? No. 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 Random algebra students is not the school. Here's the school. Here's algebra. There's a lot of people that are not in algebra that are in the school. So this is not a random sampling. This is a bias. Why? Not everybody had a chance to be asked. Okay, not everybody had a chance to be surveyed. That's why. Sample was constructed to determine what extracurricular activity at your school has the most academic issues. Okay, so extracurricular activities are your population. So all extracurricular activities. The random 25% of the men's and women's basketball teams were asked. That means you asked that. There are other extracurricular activities that are not included in whom you asked. All right, so your population is extracurricular activities, and you just asked the basketball teams. New, that's biased. Not everybody had a chance to be asked. Now, a problem that I saw in classes is students get the idea, however they say it absolutely incorrectly. And that is, they'll say, not everybody was asked. Yeah, no kidding. That's why you're taking a sample in the first place. Not everybody will be asked. That's not the question. It's not the determination between random and biased. It's not the fact that everybody wasn't asked. No. Did everybody have a chance to be asked is the question. Okay? So, anyways, moving on. You want to know about students in your third hour class. How many students in your third hour class like cheese puffs? When you take a census or a sample. Third hour class, that's what? 35 people maybe, 30 people. Third hour class, that 30 people is manageable. You want to know how many dogs usually wear collars? Population, dogs in general. Dogs. There's a lot of dogs in this universe. Take a census or samples. Identify as being quantitative or qualitative. That's a measurement. There's a number two that actually means something. Like one is bigger than the other, and it means that it's bigger or something. So that's a quantitative. Number 12, the freshman class has great school spirit. Yay! Go fight, win. All right, that's a quality. It's not like, I have better school spirit than you by a factor of 3. Now, there's no measurement in that. Great. All right, so that is your vocabulary portion of this chapter. As I said, I haven't really looked ahead too far. There might be another assignment, and if not, then we'll get into reviews. And the reviews are your closest thing to what the actual test is going to look like. So stand by on that. Again, if you have any questions or if you disagree with any of these answers or whatever, please let me know. I'd be happy to talk this through.